Welcome to our lesson about mean deviation using the median. In statistics, we often want to measure how spread out our data is from a central value. One way to do this is by calculating the mean deviation. The mean deviation is a measure of dispersion, which tells us how spread out the values in our dataset are from a central point. While we can calculate mean deviation using either the mean or the median as our central point, today we'll focus on using the median. The formula for the mean deviation using median is mean deviation equals sum the absolute differences between each value and the median, then divide by the number of values. Notice that we use absolute values in the formula. This is because some values will be above the median and others will be below it, giving us both positive and negative differences. If we didn't use absolute values, these differences would cancel each other out, resulting in a value close to zero, which wouldn't accurately represent the spread of our data. Let's work through an example step by step. Consider the following dataset representing the ages of a small group of people: 5, 8, 10, 12, and 15. Step 1. Find the median of our dataset. To find the median, we need to first arrange our numbers in ascending order. But since our dataset is already sorted, we can skip this step. Now, since we have 5 values, the median will be the middle value, which is 10. Step 2. Calculate the deviation of each value from the median. Let's compute the difference between each value and the median, and take the absolute value of each difference. Let's visualize these deviations on our number line. For each data point, the deviation is the distance between that point and the median. Notice how some points are to the left of the median and others are to the right, but we take the absolute value, so we're only concerned with the magnitude of the distance. Step 3. Sum up all the absolute deviations. 5 plus 2 plus 0 plus 2 plus 5 equals 14. Step 4. Divide the sum of absolute deviations by the number of values. In our example, we divide 14 by 5, giving us a mean deviation of 2.8. What does this result mean? A mean deviation of 2.8 tells us that, on average, each value in our dataset deviates from the median by about 2.8 units. In this case, since we're dealing with ages, it means the ages in our group differ from the median age by about 2.8 years on average. To understand the usefulness of mean deviation, let's compare our dataset to another one with the same median but different spread. Consider this new dataset: 9, 9.5, 10, 10.5, and 11. Both datasets have a median of 10, but this new dataset appears to be less spread out. Let's calculate the mean deviation for the new dataset. The absolute deviations from the median are 1, 0.5, 0, 0.5, and 1. The sum is 3, and dividing by 5 gives us a mean deviation of 0.6. Let's compare the two results side by side. The original dataset has a mean deviation of 2.8, while the new dataset has a mean deviation of 0.6. This confirms what we observed visually. The new dataset is less spread out, with values clustering more closely around the median. When would you use mean deviation? Mean deviation using the median is particularly useful when working with data that has outliers or is skewed, since the median is less affected by extreme values than the mean is. It's commonly used in descriptive statistics, financial analysis, and quality control to measure variability. In summary, mean deviation using the median is a measure of dispersion that tells us how spread out our data is from the median value. To calculate it, find the median, calculate the absolute deviation of each value from the median, sum these deviations, and divide by the number of values. This measure provides valuable insights into the variability of your data, especially when dealing with skewed distributions or outliers. Thanks for watching.